to review potential and kinetic energy, along with your light and your sound energies, okay?
Jamie Steed. I work with the 5th graders in Bond's after-school program. I kind of do a mixture of science, reading, and math, but my main dish is the science portion.
We're going to have 2 mini groups. One group will stand in front with me, and we're going to work on sound energy with our hands-on lab. And the second group's going to go in the back with Mr. McGee and work on wavelengths. Then everyone's going to break off with your partners, and we're going to work on homework, okay? Any questions?
No, ma'am.
All right.
It's not just a learning experience and working on homework here at school. We actually give them life experiences they would not normally or necessarily get. Not only are they covering their homework, but they're actually getting a chance to go out and apply what they have learned. And there may be a question on their homework or on a test. And just from that experience, they know the answer.
All right, the first thing we want to do is review potential and kinetic energy. Remember what
During regular school hours, we have been studying the different types of energy and how energy is transferred.
Of something, and when it
Today in after school, we went over a lesson on potential and kinetic energy and also studied a little bit of sound and light energy.
Keep going.
As it goes down, it loses potential and it goes into kinetic.
You're absolutely correct. Just like a roller coaster. Who's been on a roller coaster?
Me.
You ever ridden down and you're like, ooh, my stomach kind of felt a little funny. That ever happened? Okay.
By teaching day school and after school, I'm really able to work with the students that I know need extra help.
The moment you start going down,
you lose
the potential energy is transferred into kinetic. Absolutely correct. Now, this right here is sort of a homemade guitar. I don't know if we could really write a lot of songs and play off of this one or not. But with our little wire we have here, if I was to pull it, what type of energy is that?
Kinetic. I mean potential.
Why?
Because it's not moving.
Because it's not moving. As soon as I let go,
it loses potential and it goes into kinetic.
Now, what I want you guys to do right now is just kind of play around and show me potential, kinetic, potential, kinetic. Just play around with it.
This potential, this kinetic.
And we went over sounds and vibrations. And there's another group going on at the same time with Mr. McGee, who's actually a student at one of the local universities. He works with the kids on wavelength.
Hold it tight. We'll see it bounce up and down.
Remember when we discussed simple machines? And we said that a simple machine did not have any type of electrical energy? This is a simple machine that has a lot of different levers and twists and angles. Everything's going on. This is called a music box. We twist for a second. There's these little prongs, looks like a comb, and then there's little bits sticking out here. They kind of pluck that, just like we do to the guitar, just like this. And that's what creates the music. So watch it. I'm going to let it go really slow.
I really think that the structured after-school homework time helps the kids. And I see a really big difference between the students that are in the program and the students that are not. And I see a big difference in test scores.
So what's creating the sound from the music box?
Vibration.
The vibrations. And what's making the vibration?
The sound.
Not the sound.
The potential.
These little barbs that are kind of sticking out from the little spool, they are actually plucking the little pick-like material.
Like when we pull this.
Just like when we pull here. And they're causing vibration. Here you go. Play with.
And they would take that lesson and it carries over to the wavelength lesson that Mr. McGee went over with them.
All right, we ready? All right, now we're about to study how a wave moves, okay? Now, the highest point of a wave is called what?
The crest.
Crest.
Wave.
Exactly. The lowest point is called what?
The trough.
All right, I want y'all to hold it nice and tight. We'll see it bounce up and down.
When Mr. McGee took the kids outside today, the lesson was on wavelengths and figuring out where the crest and the trough is.
Watch it vibrate.
Wow.
That's showing how a wave moves, up and down, up and down.
After that, they actually had a chance to see different wavelengths of light.
What colors do we all see?
Red, orange, yellow, green, blue, and violet.
Now this is called the visible light spectrum. These are all the colors which are visible to us. Now as you see, all the colors stay in a certain what? Order. And you see that because each color has a different wavelength. Therefore, it forms a certain order, okay?
Yes, sir.
All right.
After that, all the kids came back to a group and we kind of spread out throughout the classroom so that everyone can ask their own questions and complete their homework assignment.
All right, guys, what we're going to do now is you're going to take what you did in each group and you're going to apply it to your homework assignment. Everything we went over today is going to be on your homework. So if there's any questions, you have to ask us, okay? We want to make sure that everyone understands.
I helped my friend Laniquia. We were doing homework on kinetic energy and potential energy, which is when for example, when a ball is sitting on top over here, it's potential energy, and when it rolls down here, it's kinetic energy.
So let's say you have the ball right here. What kind of energy does it have?
Potential.
Okay. And then you roll that ball down the hill. What happens?
1,531 speed.
It speeds up. The potential energy is not there anymore. It's going to be converted into... What's the other type of energy? Look at this diagram. It's telling you that this car has the most potential energy because it's sitting here at rest at the top of the track. Whenever it moves, it says a small amount of potential energy is transferred into, what's that word? Kinetic energy. So imagine that you have that ball here as what kind of energy? Doing no work. Potential energy. When you let it roll down, that energy is converted into, so if you had to put it in sentence form, explaining what would happen to a ball if you rolled it down a hill, what would you tell me?
Which substance does the particles move faster? It moves faster.
The ball is sitting on top of the hill, not doing anything. It's kinetic. Kinetic energy.
You know when the teacher tells you all the time that you have so much potential that you could get the grade if you want to? You haven't done it yet. You have potential. Once you do it, then you have kinetic, okay? So if the ball is just sitting there at the top of the hill, it's not doing anything. It has potential. So at the top of the hill, the ball has energy. When it rolls down the hill, the potential energy is converted into, that's it. At the end, I'll usually tell the kids, now, if you have a problem with your homework, if you didn't finish it today, just write the number down, come back to school tomorrow, and we'll go over it. I don't want you stressing out. I don't want your parents stressing out. We're going to handle it together.
No, there you go.